Hello and welcome to Take 5 with Automation World. I'm David Miller, Senior Technical Writer at Automation World. Today, I'm going to be talking about Single Pair Ethernet and Ethernet Advanced Physical Layer, which I will henceforth refer to as SPE and APL for short. And the reason I'm talking about these technologies is because they really are fairly new. And so while many have heard of them, they may not really know what they're all about. So the first question here that obviously needs to be answered is, what are SPE and APL? And we'll start with SPE. SPE is simply a form of Ethernet that uses a single twisted pair of wires, whereas other forms of Ethernet use 2 or 3 twisted pairs. So it's really a very simple and minute distinction. But because of this, SPE has a smaller footprint, and the cabling can be run up to 1,000 meters without signal decay, which makes it ideal for very expansive process industry environments, such as an oil field or a large wastewater treatment facility. Now, on top of this, SPE has some very particular specifications that make it useful. While it's slower than other forms of Ethernet, it's still a lot faster than field bus. So what we're looking at here is basically a Goldilocks kind of situation. With field bus, the porridge was too cold, meaning the bandwidth was too low. Whereas with a typical industrial Ethernet connection that's prior to SPE, the porridge was too hot, meaning that it was over-engineered, there was more bandwidth than was needed, and that meant it came with other drawbacks, such as, again, more limitations on that cable length due to the need to maintain that signal. SPE, by contrast, is just right. It gives those in the process industry the long cable runs they need in those expansive environments, and at the same time, the bandwidth they need, and hopefully at the right price point. But now, what about APL? So APL is simply a variant of SPE, which is intrinsically safe via adherence to the IEC 60079 two-wire intrinsically safe Ethernet standard. And it's a mouthful, I know, but we simply call it 2Ys for short. So being intrinsically safe, again, simply means that there is a limitation of voltage on the wire itself so that it cannot, under any circumstance, pose a risk of igniting a spark or explosion in an atmosphere that contains dangerous gases or dust that may be flammable. Again, we're looking at process industry environments. So let's talk about a use case. I recently attended an Ethernet APL online workshop during which chemical producer BASF spoke about some of what they've been able to achieve by employing this technology, and that is APL specifically in their case. And it boils down to a few things. So one, because they have more bandwidth, they're able to pull maintenance and engineering data from their devices in addition to process variables. And this is allowing them to construct a digital twin of the operational environment. Now, the second thing is because they're aggregating more historical data across the entire life cycle of their assets, they have developed this large pool of time series data, and they're able to mine that for patterns and correlations, either using human data analysts or with the assistance of AI, which allows them to begin engaging in predictive rather than merely preventative maintenance. They're finding these patterns, why things break down and when, and they're learning new things about why it happens. And finally, it's the case that APL has helped them not only in pulling more data from equipment that's already in place, but also in more quickly commissioning new equipment as well. And this is because the greater bandwidth of APL essentially makes it so that a repository of data needed for integration, such as field device integration packages, operating instructions, and security certificates, can be stored on the devices themselves and then transmitted over the local APL network rather than being downloaded from the internet. So this means, or rather this may seem like a small thing, but when you might literally need to integrate hundreds of devices, it can really save the people doing it a substantial amount of time to not have to bring in all of that externally to have it right on the devices. So now there's just one more thing to note here before we conclude, and this is that should a company want to make the transition to APL, it can be done with existing field bus Type A cabling, which can be very convenient if that cabling is entrenched or buried, somehow difficult to remove, which again may be the case in process industries. And so the only caveat with that is that in order to be compatible with APL, the devices do need to be manufactured with the appropriate physical transceiver, or PHY as it's sometimes called. In any case, that's all for me today. If you enjoyed this, you can read more about SPE and APL in the links below, and you can keep your eyes on this space for more segments like this to come in the days ahead.